Hey everyone, this is Bradley Bush. Today we're talking about the average rate of change, which is a form of slope. If we look at the graph that I've drawn here, this picture right here that I've circled in pink, let's check this out and it might help us understand what's going on. So the graph we're interested in here is the red F. And we have a couple x values. We have x1 and we have x2. So x1 and x2 are just random. We don't care what they are. We could put numbers to them if we wanted. Like, for example, x1 could be 2, x2 could be 4. All we care about is x2 is bigger than x1, but we want to leave them actually generic, just as x1 and x2. So they're just random numbers. x1's to the left of x2, but that's all we care about. If we shoot x1, for example, up to the graph, we'll see a value there. That value will be, right, y1. We're going to call y1 instead of y1, we're going to call it f of x1, like you see here. In other words, we plug in x1 into the function f, and out pops the y1. Same thing over here with x2. We're going to shoot up x2, we're going to plug it in, and out's going to come y2. So really, f of x2 is just y2. That tells us that this right here is y2, and this right here is y1. So this actually looks like this m, this slope function m, is actually exactly like the slope function you've been dealing with in algebra. It's y2 minus y1 over x2 minus x1. That is perfectly just rise over run. So it's just slope. That's it. Where then does this word average come in? Why do we say average rate of change? Well, the thing is, the slope of the green line you see, this green line right there, the slope of that green line is the same as the slope, the average of all the slopes in this yellow area right here. Let's clean some of this up. See if we can clean some of this up, and it'll help us out a little bit. So in other words, there are a bunch of x values in between here, right? There's a slope there, there's a slope here, there's a slope here, there's a slope there. So all these x values have points associated with them on the graph, and all of those graphs have slopes. But if you look at them, they're all a little bit different, right? So if you took all of them in this entire area between x1 and x2, took all the slopes on the red curve, and you average them together, that would actually be the exact same as the slope of this green line. That's really remarkable. So all you have to do to find the average of all of the slopes right there is just take the slope of the two endpoints. Our two endpoints are x1 and x2. So we take those 2 points, draw a line through them, find the slope of that line, which is just the basic rise or run, and we've got the slope of all of, the average slope of all of them in between. Perfect. That's actually a really remarkable idea. So again, to repeat, the slope of the green line between x1 and x2 is the average of all the slopes of the yellow region on the red curve. Super nifty. So let's do a little algebra to help us kind of give an example. So say we have this example here. We want to find the average rate of change of this function, x squared minus 3x, between the x's of 2 and 5. So we just follow the formula. Our formula is right here, and we're literally just writing it out. So this gives us f of what's x2? Well, x2 is 5, minus f of what's x1? x1 is 2, all over 5 minus 2. So we have f of x2 minus f of x1 over x2 minus x1. And we just keep going now. So the f we said was x squared minus 3x. So we have something squared minus 3 times something. And that something is a 5. And we will subtract that from f of x2. So we will have something squared again, minus 3 times something. And this time that something is 2. And this is all over 5 minus 2. So that gives us 25 minus 15 minus 4 minus 6. This is all over 3. 5 minus 2 is 3. That gives us 25. That's not a good 5. Let's do that again. 25 minus 15 minus 2 over 3, which gives us 10 plus 2 over 3, which is 12 over 3, which is 4. That is our average slope between, that is our average slope between the values of 2 and 5. Okay, let's do one more quick example. Here's a graph of the number of active duty gay servicemen discharged from the military for homosexuality. This is a good picture because it has a lot of up and downs, so let's use it to show how to find the average rate of change. So if we want to find the average rate of change in the discharges between 1994, well, that wasn't what I expected, 1994 and 2006. If we look at our graph, 1994 is right here. So this is the point we're interested in. And we have here an X and a Y. And what's the other date? 2006. Where's 2006? Right here. That's the point. And again, we have an x and a y. If we call the 1994 x1 and y1, then this would be x2 and y2. Now we can just fill out our formula here. So we know that we have f of x2 minus f of x1 over x2 minus x1. Instead of doing f of x2 and f of x1, we can just use y1 and y2. That's the same thing. So we'll make a little note. This is y2, and this is y1. So now let's go fill it out. It's actually just going to take a couple seconds here. So f of x2, which is the same thing as y2, is 623. And we're subtracting 617. And we have 2006 and 1994. When we subtract the top, we get 6. When we subtract the bottom, we get 12, which gives us 1/2. So the average rate of change in all of this region, in all of this pink region here, if you took all of the slopes and averaged them together, you would end up getting 1/2. So that's the average rate of change for the discharges between 1994 and 2006. That's it. If you guys have questions, let me know. You can leave a comment or like the video or subscribe to the channel. Thanks a lot.